Okay, this is activities 2 and 3 for 6.1. We're going to be going through and actually identifying outputs and inputs, and we're going to describe possible situations. So it says work with a partner. How many outputs are assigned to each input? So this we're learning how to actually read this diagram. So when you have arrows, it's just telling us in this situation that when we put an input of 12 in, our output is going to give us 6. So this is our X's and our Y's. It's kind of like a set of coordinates. Notice how these are connected. So the next one that we have would be, well, when we have 23 as an input, our output, we get 15. So 23, comma 15. So that one only had one output. Okay, the input of 30, when we put that in to our equation, it gives us 20, 30 to 20. And then 48, when we input it, it gives us 13. Now, we don't know currently the equation, but we know that each of these inputs had exactly one output because they only had one arrow going away from each number. So how many outputs are assigned to each input? Well, in this case, one output was assigned to each input. So it says, give a situation for each mapping diagram. Now this is where it's going to vary. We don't have to give a specific situation, but where's a situation where we would just have one output with each input? Well, it might be maybe like if you think in terms of like basketball, each person could only have the one basketball number. Like I can't have two 24s out on the basketball court. So that would be a situation where we would only have one for every scenario. Okay, so letter B, we've got an input, and you'll notice on this one, we have two arrows coming off some of these. So what they're telling us here is sometimes we're gonna have a 10, 0, and sometimes we're gonna have a 10, 1. So how many outputs did we have there? Well, we had two outputs on some of them. On 10 and 12, the inputs, we had two outputs. And we'll find out in future lessons that this would not be considered a function because we cannot have more than one output per input. And we kind of discussed that on the first set of videos. So the other ones, well, 13 had an output of 2 and 11 had an output of 0. It's okay for two inputs to have the same output. We just can't have two outputs for the one input. So you'll notice both of 10 and 11 had an output of 0. Okay, so in this situation, two of the numbers had two outputs and two of the numbers had just one output. So where's the situation where this might occur? Maybe let's go back to the basketball reference. Maybe this is a scenario where we've got, well, I was going to say we could say it was the number of points somebody had, but like player 10 couldn't have 0 points and then 1 point. So it could be maybe the number of people. We could do something with maybe the number of people that did something. So like maybe 10 people had 0 desserts and 10 people had 1 dessert. Okay, it doesn't have to be the same 10 people, but maybe if this was a party, in the next scenario, like here we have 11. So 11 people had 0 desserts also. Here we had 12 people that had 1 dessert or 12 people that had 3 desserts. And then 13 people had 2 desserts. So it's just coming up with a situation in which that scenario might work. Once again, in letter A, we do have a function because each input had exactly one output. And in letter B, this would not be considered a function because we ended up with 2 cases where they had more than one output. All right, let's go ahead and move on to activity 3. So that's just learning how to read your function diagram or your diagram. So interpreting a mapping diagram, it says work with a partner, describe the pattern in the mapping diagram. And you guys don't have to copy and complete because you have it right in your book. So when you're finding a pattern, for right now, the pattern that we're going to look at is what is happening between each of these. So to get from 1 to 2, we could either go times 2 or we could do a +1. So we're going to check to see what's the next one show us. Well, to get from 2 to 3, it wouldn't be times 2, so it can't be that one. It would be +1. So in our input, we are adding 1. Okay, so what are we doing in our output? Well, 8 to 10 plus 2. We could be taking it times a decimal, but let's check to see first if we're doing it +2 every time. 10 to 12 is +2. Okay, so let's go ahead and finish out the pattern. If we do a +2 here, 12 plus 2 would give us 14. Plus 2 would give us 16. You can see the pattern. 18. And you guys, a lot of you have done that when you've had to go through in previous sections and work through and graph equations. You guys would look for that pattern. So our output pattern was we were adding 2. Now it's not always adding. Sometimes you're multiplying. Okay. So let's go ahead and look at letter B. So letter B looks like it's a +1 again. So output is not output, sorry, input is +1. And our output, we're going to have to figure out, looks like we're working with some fractions. Okay, so from 4/3 to 5/3, looks like we're doing a +1/3. So if I add 1/3 to 5/3, that would give me 6/3, right? Which is the same as 2. So we're adding 1/3. Okay, so 2 plus 1/3 would give us 2 1/3, or you could do it as 7/3. If you want to do it that way too, you could do 7/3 or 2 1/3. I'm just going to do 7/3 because it's easier to write in that little box. So if we add 1/3 to that, it would give us 8/3. If we add 1/3 to that, that would give us 9/3, which is the same as 3. And if we add 1/3 to that, it would be 10/3, or you could have 3 1/3. Okay, so our output, we added 1/3 every time. Okay, so that's just working with finding the patterns. You're going to do a little bit more of that within the lesson. Good luck with this. Just remembering our inputs. When we check the patterns on an input, we're checking from one input to the next. Sometimes it's adding, sometimes it's multiplying. When you're checking your output, it's the same thing. You're going from one output to the next.